who here has heard of, who here has at least watched or heard Conrad's talk on computer-based mathematics? Okay. Now, I'm very, very glad that Conrad has sort of taken this approach. I'm glad that he is, changing the conversation about what is important and about what we can possibly do to teach mathematics differently than we've been teaching it before. We know for a very large segment of the population that people aren't getting mathematics, okay? And he goes even further than I ever thought I would go, and he's saying, look, let's just teach computer-based mathematics, right? And let's certainly de-emphasize, at least initially, the calculation aspect of mathematics, which I agree with. Students tend to get caught in the forest. They can't see the trees because what they're worried about is getting the calculation. They can't do very many calculations, right? So trying to use a finite set of calculations that are somewhat artificial in order to elucidate the conceptual and visual and abstract side of mathematics seems somewhat ridiculous, and I've used the analogy of music, to describe this. Trying to use calculations in order to teach mathematics is like trying to teach notes on a piece of paper in order to get people to see and hear and see the beauty of music, okay? And we're just stuck into this habit. But now that we have this computer, we have a new tool in which to approach this thing. Now, and I attended this conference last year in London. They formed this organization, this computer-based math organization. It's certainly a good place and a focal point to start the conversation. More of us need to get into this conversation than just Conrad. We all have different opinions and viewpoints on what computer-based math should be. Okay, but some of the takeaways I get from when he talks about this stuff, at least my takeaways, is why is there this complete focus on hand calculations? Now that we have this tool, right? Shouldn't we be teaching them how to use this tool in order to explore mathematics? You guys are different than any other audience I might talk to because all of you do computer-based mathematics. That's why you're here. You learn mathematics, you explore mathematics, you're doing all of those things, right, that I believe we should be teaching our students to do. So why is this complete focus on hand calculation, right? Certainly it's tradition, and certainly, the great mathematicians can rise above and see the forest for the trees by doing these calculations, but that's not the general population. This is a very finite set of people. But we want to increase the probability that someone understands something. And in my experience, using Mathematica and teaching this stuff, is that once you actually understand the models and the structure of mathematics, then those calculations are trivial, okay? We've all experienced students repeatedly asking us what we see as the same question over and over and over again, right? Because what you will find is that if you start giving oral exams just to your A students, the people got 100 on your exams, if you gave those people oral exams, you would find that most of them, they do not have any idea what they're doing, okay? We are proceduralizing these calculations so that they have success in doing those calculations. And to minimize their energy, they are simply forming a matrix of problem to solution, right? It's the match game you play. And it's like, okay, here, I have this problem, I do this procedure, I get this, okay? You give them something that uses the same conceptual base, right? The exact same conceptual base. They do not recognize the problem. They can't solve it, right? And that is because they can't actually explore mathematics by doing calculations. They can't do them fast enough. They're not confident enough in their ability to even get it right, okay? Trying to graph a 3D graph of some of these things takes hours. It's like, that's not very good use of time to actually try to explore mathematics. And then I bolded this one thing here because I want to talk about this a lot because Conrad certainly emphasizes this early in his talk. I think Conrad gives 2 talks. And the first part of the talk is brilliant. It's fantastic, okay? I love it. And he talks about using the computer to solve math problems, right? We all do it. I do it, right? It's like, my first reaction when I get a problem is not to sit down with a piece of paper. I open up Mathematica and, try to figure out this stuff, right? And, he says that most of these hand calculations that we give are somewhat artificial. Why? They can be done by hand, easily. He says that students can access more mathematics problems with a computer. That's certainly true. Like, we can give more real-world problems. We can have them do real things that are relevant to their lives. What about using the computer to build concepts from the top down, from that conceptual 30,000-foot view, where they can have Mathematica do the graphs, do the calculations, right? So they can experiment and see all of this stuff and see the patterns and see how it works together. What about that? And then I found once you've got that, these calculations aren't hard, right? And what about the computer really as just a brand new interface to mathematics? A guy named Brett Victor, he was one of the lead designers of the iPhone, wrote a blog called Kill Math. Okay, I suggest you read it. And he's saying, look, we have a new user interface to mathematics. Let's use it. Okay, and let's figure out how to use it. So these were my takeaways. These are the things that I really liked we talked about. So, so what has been going on? How have we been using computers? Okay, and this is where I'm very, very disappointed in education. Here we have this wonderful machine. It does computations. It is a tool. Okay, and what are we doing? Well, we're treating it as a TV. Okay, we're using the computer to treat it as a TV. There's a course, and I got this screenshot off of Coursera. Okay, that could be another hour of me talking just about Coursera and these MOOCs. Just let me say, when I think about MOOCs, I smile. Okay, I smile. My first reaction is to just despise what's going on there. Okay, but I actually think, one of 2 things is going to happen. First of all, what I believe is that they're going to fail. They don't really have a business model. They've taken what used to be 600-person lectures that everybody despised and turned it to an 80,000-person lecture that everybody will despise. But what they're really doing is they're actually marginalizing, okay, and showing how valueless lecturing is. Okay? If they fail, we're all like, okay, that failed. Maybe we should do something besides lecture. If they succeed, okay, then they're saying, you as faculty members, okay, you should find something else to do, okay, of more value, so that students come to you rather than going to them. Because if you are replaced by MOOCs, you deserve to be replaced by MOOCs. That's what I want to say. We're using it as a video chalkboard. I got this from Khan Academy, right? More lecturing, more chalkboard, okay? Still very, very, it's like, okay, how do we teach? We lecture. Here it is, okay? Also marginalizes lectures. What good are your lectures when he's doing them, okay? The one nice thing I like what he says about this is stop lecturing, I've got it covered. Yes, we all know they're not that great. I've got it covered, do something else. And so part of what I'm going to talk about today is what else do you do if you're not lecturing, okay? He says, you know, have them watch these lectures and do some activity. But he didn't give you that activity. And you know what the hard part is? Is getting people, these students, to do activities, right? Pretty easy to watch a video. It's hard to get them to actually work and do something. Still more video chalkboard. I think this is Udacity, okay? And everything, and it's wonderful, you know. With technology, man, it's just awesome, right? Oh, the other thing we're doing is, you know, mechanical graders. Wonderful, okay? We're teaching these people to be mathematicians. Look at this. They can like go and get a wrong answer, or they get a right answer, okay? And they play around until they get the right one. They have no idea why they got it. Still more mechanical grader. This one's Alex, right? And the other one here is, I believe that's WebAssign, okay? These are successful businesses because they're appealing to the laziness of having to grade papers and the depression of seeing people get things wrong. Very good business plan, very good. Now, this is a little controversial in this room. This is how else we're using the computer. We're giving them demonstrations. Here's a demonstration, okay? Look, you can slide these things around. It's wonderful. Now I come back to what Conrad says, which I think is maybe the most important part. We're teaching computer-based mathematics. Okay, we're teaching them. We want them to solve problems using this thing. Okay, how many problems can I solve by changing these sliders around? The problem's been solved. Okay, they're just looking at the solution, but we haven't taught them to come up with a solution. Okay, and this is a lot of what's going on, and it's easy to distribute. There's CDFs. There's all these kinds of things, right? But the students aren't getting to have, when I hear people talk about it, it's like, look what you can do. Look what you can do, right? And guess what? That's pretty fun. We're Mathematica users. Yeah, look at that. I did that, And they look at that and they're like, it's mysterious. It's really cool you did that. You're a good guy. Thank you. But then something big happened yesterday. Something big happened yesterday. And I think what's going to happen here is that this company is going to realize that their real value is Mathematica, right? Mathematica is the new user interface to mathematics. It's the best user interface to mathematics in the world. Okay? I don't have to convince you guys that. You're here. When I go to other talks, they're like, I don't know, it's scary. Okay? But this is the new user interface to mathematics. All right? And if you build courses, and you're going to have access, if you build courses and share them out with everyone, and you give access to Mathematica, free-form Mathematica, these students, you're going to see enormous difference between that and just giving them these demonstrations, because they're going to be creating their own. They're going to be asking questions that you did not anticipate. All right? They are going to become you. Okay? And just a quick note, one of the things that I don't think is talked about very much is the genius of Stephen Wolfram. Stephen Wolfram, not only, the reason he created this company, right? Because Mathematica didn't exist, and he wanted to do computer-based mathematics to learn the mathematics himself, right? How brilliant is that? And he had to build a successful company that brought in money to keep the R&D going, just to catch up with him for what he needed to do it. Now, I'm not saying we're all going to be, all these people are going to be Stephen Wolframs, okay? But that same concept applies. So what's going on here? So we got the online Mathematica, all right? And here's where it's going to look like I'm a vendor, but I'm an advocate. Okay? I don't want to sell any on this. Okay? But I do want to use it as an example of what's possible. So we had online Mathematica. Well, Wolfram has been working with us, and they allowed us to create an early version of Mathematica Online. Okay? And eventually we're just going to be, we have our own servers, we build our own user interface, we build all this stuff, but we cannot keep up with Wolfram as far as like just making cool stuff, right, that it'll do. So we want to use their servers for the calculations and then keep things on our side. And the main thing to see up here is it's learning math by making math, okay? Well, what are they going to use to make math with? They're going to use Mathematica, right? And if you want to have conversations, if you want to do social networking, if you want to do these things with, a lot of people have tried to use social networking to get students to talk about math. Well, they really don't have anything to talk about. You have to talk about cats, right? I don't know, people love cats. And so, but if you have Mathematica and they're making something, they can talk about what they're making. If it has an error, or it has something surprised them, or they're proud of something, they have that to talk about. It becomes a base for not only you to talk to them about it, but they can talk about it with their fellow students. Okay? So, we're all about learning by making. Other parts of my company, I know we've heard of Make and Maker Faire and the Maker movement. They're talking about making physical things to learn science. Right? And that's having a big impact to the point where the president is talking about it. So Mathematica, user interface to mathematics. Okay? How about a user interface to computer-based mathematics? So now you need a teaching environment, right? Well, it's not good enough. Okay? It's not good enough to have scattered resources without a narrative structure, okay? The old days of constructionism, and a lot of experiments have told us that. If you just simply throw a bunch of tools in a room, yes, the stars of the room will make cool stuff and learn stuff. But without some guidance and some A to B to C structure, just giving people a bunch of resources is not going to be effective. We got to give them a path, we got to give them goals, okay? And then we want them to go perpendicular and be able to use freeform Mathematica to grab a hold of this, power to explore mathematics very quickly. All right? So, now let me just show you. This is where it's going to look like a vendor. But just think of this as sort of an example of how to use the online Mathematica. Right? You now have a new tool in which to teach. And it makes online Mathematica, it's going to make, it's as big, it's a big of a difference as when people were using Unix machines and using Gopher and FTP. I don't know if the younger people here knows, but people were using the computer and exchanging files all the time. But once the web came up, it made things way more accessible. Document management went away. There was a view source, okay, where people could make more things, and it just exploded. Right? To me, when I look at the future, this work that Mr. Tom Wickham Jones has done back here, I think is one of the most important things I have seen this company do. So let me first show you I'll show you a student view. So remember, so what we're doing here is we're using a version of online Mathematica. Eventually it will be the version of online Mathematica. It's all on the web. you know, so I don't have to repeat that yesterday. You know, it's like, this is not, you know, I had a problem even submitting my talk to here because I don't own a copy of Mathematica. I do all my Mathematica here. And I had to have my talk in NB files, and it was kind of difficult. But so, you know, so all of these cells run. You know, this, but notice that there's a narrative structure and computation. So there's a discussion and computation, right? This is not a lecture, a book, and then a lab. This is the textbook. This is the learning management system. This is everything. This is the way this is all the communication. Everything is focused in this process, which completely changes the way that you approach teaching the mathematics. You can build it up in pieces. You can have them do these calculations and experiment with it to see the patterns. You can ask them to do problems, all right? And when you do that, and then you give them written exams and you give them written things, they can actually get them, you know, it's much easier for them because they know what they're supposed to be calculating.
Is the student actually writing the mathematical code here? All of, you know, this stuff was written by Jerry Yule, okay, at the University of Illinois. And no, so this is all done, right? Okay, so they do have demonstrations, okay? But notice that the demonstrations all have code in them. Okay? They learn that. Okay? They want to do things. They're asked to solve problems. One of the biggest questions I get when I am being a vendor and I'm trying to sell this to somebody is, are they going to get the Mathematica code? Right? And I'm like, well, are they going to get the calculations? Right? This is mathematics. The ranges, the viewpoints, all of these kinds of things is mathematics. It's all solving mathematics. Okay? This is a user interface to mathematics, right? And so they you know, they're not hung up on these kinds of things, right? It's more of the teachers, not in this group, but it's more of the teachers that seem to be apprehensive about it, right? Because they think it's this scary programming language, but it's actually mathematics. It's very natural. So you'll notice our structure is we have basics and tutorials. Okay? So basics, 30,000 foot view. Let's look for these patterns. Let's see what's going on here. We have tutorials. How do you solve a problem using these tools? Okay? Let's solve a problem. And we're talking about solutions, not answers. Okay? Then, you know, they hand these things in. Okay? You know, when we do these problems, you know, all of their stuff comes up. All their stuff comes up in these green. You know, every time I make one of these cells that's green, I can turn them into text cells. We type these in. It's like you know, I'm just going to be all like, hello, I don't get it, or something. Okay. You know, they can say these things. They hand them in. The whole thing is structured. Now that we have separated the front end into this web-based things, that gives us access to all kinds of web-based technologies and techniques and stuff like that. For instance, we have an overflow, which is it hooked up on this end? We have an overflow. You know, I don't get the plot 3D or something. Okay, continue. Okay, and now instead of having text areas, okay, our text areas are what we call notebook cells. And they can ask their question in a text cell, put in their thing, and now they can communicate back and forth with Mathematica. Message systems can be made. Okay? We're adding Facebook-like social networking to all these things, where you can comment on every cell. So this becomes a social networking basis for conversation, right? And hopefully now, if they're talking about cats, they're talking about a mathematical representation of a cat. And then, of course, you know, how do you, then we have a mentoring. We use a queue-based system. The students handed this in. We click on it, opens up. We add our comments, send it back. We say that in the first 3 weeks of a course, you know, if you were going to do something like this, you must. So let me get something straight here. This computer, awesome. Mathematica, awesome. All this stuff, awesome. The most important person, the most important thing, the most important aspect of this whole thing is the instructor. Okay? This is an empowering environment. You know, all we're really giving you, we're turning you into a coach. All we're really giving you, and all Mathematica is really giving you, is the court, the hoops, the basketball, okay? And now it's time to coach. And your attitude and the way that you answer the questions, the way that you converse with these students is the most important thing. This is an empowering thing, okay? Let me show you the course manager, which is this is how you publish. So this is a complete publishing environment, all right? We start out with canned courses, right? Completely canned. Right now we have 8. We're adding 3 more as we speak. Digital signal processing. We have all kinds of people who want to put content in here. But all of this content is editable, changeable, right? You set your course, you import it. It goes into your courses, where now you edit it, make some changes, right? For instance, you know, these who were written by Jerry, you know, he has a lot of jokes that were only funny in 1950. So you might want to change those things, right? But it's completely up to you. But at least you have a template for which to start. But you can make an entirely new courses, all right, in this system. There's a 4-stage thing. You import it, you stage it, okay? When you stage your course, you're adding all of the parameters for your course. When does it start? When does it end? Is it rolling enrollment? You know, what's your name of your course? Who are your mentors going to be? Who are your graders going to be? So they get access. Yeah. Then you activate a course, right? And when a course is activated, now what happens is a unique URL is created for you, right here. Okay, that is what you send your students. Okay, and they go and they buy that. They buy access to that. And then that's your course or your section that they get logged into. And that forms that group. And you're ready to go. So the model at the college level is just like textbooks. You guys don't pay anything. Okay? You are in here to adopt this, okay? Now we're only going to give you so much time. We have to make Wolfram happy, right? Our goal is to make Wolfram lots of money and create fans of Mathematica. Many, many, many fans of Mathematica. So let's see, so we have, you know, great plans here. We can share content. Everybody loves sharing. Okay, we can share content. You can share that content within your school, so that your colleagues in your school, and so you can, you know, every school is going to have something they want to emphasize, something they want to do, and you can share it publicly. And we have
two models for this type of publishing. We have some people who just are want to share things sort of in an open way. And when you do that and you mark it open, it means that that content you made can be edited. Every piece of it can be edited, okay? If you want to protect it because you're very protective and you don't want to be misrepresented, or you can protect it. And if you protect it, you can put a price on it. If you think it's good, you put a price on it. And when all of those little units and lessons and things are put in, if you add one that is protected, we let you know, and it adds to the price of that student access. So that we didn't have to, because if you start going into the royalty process, if 20 different people wanted royalties for a course that had 20 lessons, we can't fund any more development of this. Okay? So it creates a market. So those prices can be changed and chosen so the market can absorb those types of things. And just because now this is all separated on the web, our ideas for making all of this even more useful is far exceeding our ability to keep up to programming. All of these social networking aspects that, like Facebook, should be absolutely part of this system. And also it gives us the ability, we can create new kinds of cells. One that I'm going to be, when I write a course, I'm going to be using this a lot. Let's go back to regular frames. And let's insert. There it is. I'm going to insert. All right. We created this new structure. It's a solution cell. When my mentor, Bill Davis, he said, don't accept the answer as the answer. Let's make these people create solutions. There are answers and there are solutions. Let's make them create solutions. But let's teach them how to do that. Well, who taught us, at least me, who taught us how to make solutions? Well, George Polya said, hey, here's a step-by-step way of making solutions. Who's heard of George Polya in here? Anybody read this thing? Right? It's like you only have to read 3 pages and you're like, oh, okay, I'll do that. So we are actually asking them, here's what a solution looks like. Right? You restate the problem, identify what's being asked for, you write down a short plan, you make the estimates of what you think that answers are going to be. Then you just carry it out. This is the part that most people only answer. And then, we summarize it. What'd you learn? What'd you find out? Was it anywhere close to what you thought you would get? Does that make it wrong? So the goal here is not teaching people mathematics. It's teaching them to become mathematicians. Thanks.